Number 3, HCN is being titrated by NaOH. I need a net ionic. Transfer a hydrogen. I need to know what would be the pH at half equivalence. That would be when pH equals pKa, which will equal the negative log of 6 times 10 to the negative 10th. Negative log 6e negative 10, 9.22. C is using language here about endpoint versus equivalence point. If we have the correct indicator, as it says in E, the endpoints and the equivalence point are the same. And it's the point where we're assuming we have added the right amount of hydroxide so that its moles equal the moles of HCN. So this would be 20.5 milliliters of 0.15 molar NaOH. To have the same number of moles being equivalent to 24 milliliters of the HCN. So similar to the problem up above, I can do molarity equals moles over liters to get the moles of NaOH, which I'm going to assume are the same as the moles of HCN. So now to get the molarity of HCN, its moles over its liters. Okay, D is a pretty easy question because I already found it. How many moles of NaOH were added to reach the endpoint, we already figured that out. Now, I need to find the pH at equivalence. This is a bit more work because I'm going to create some of the conjugate and then I have to consider hydrolysis. So for E, I'm looking at my net ionic reaction, which I wrote earlier. At equivalence, we have 0.00375 moles of this, 0.00375 moles of that. These both go to about 0, which means we have then created 0.00375 moles of CN minus. CN minus is a weak base. So since this is a weak base, I'm going to do a problem where I have Kb equals x squared over the concentration of CN minus. So I need to get its molarity. CN minus is moles over the total liters. I've got to back up here. We had 20.5 mLs of that, 24 milliliters of that. So that looks like 44.5 milliliters total. So 0.00375 divided by 0.0445 liters gives me 0.084 molar. Now I need Kb for CN minus. I don't think I was given it. I think I was given Ka for HCN. Yeah. So I'm going to use this to calculate Kb for CN minus. Ka times Kb equals 1 times 10 to the negative 14th. So Kb will equal 1 times 10 to the negative 14th over 6 times 10 to the negative 10th. 1e negative 14 divided by 6e negative 10. 1.67 times 10 to the negative 5th. That's my Kb, so now times my concentration, square root of answer, and I get x to be 0.00 118. That'll be molarity of hydroxide. So now I can get POH and then I can get pH. Negative log gives me 2.93. 14 minus that, I get 11.07. Feel like I should be done with this problem, but there's more. Starting pH of the titration. That means I want the pH of the HCN alone. I know that the HCN has a Ka of this. And earlier I figured out what its molarity was. So let's go back up here. This number here. So this is a weak acid problem. X equals 8.76 times 10 to the negative sixth, and that's H plus, giving me a pH of 5.06.